All right, let's talk about something really important in the world of AI: bias. You might think it's some super complex bug in the code, but nope. The real problem is actually way closer to home. It all comes down to the data, the very stuff we use to teach these systems. So let's break down how that happens.
Okay, let me ask you something. Have you ever, come across some new information and just kind of ignored it because it didn't fit with what you already believed? Of course you have. We all do it. It's just human nature. And that simple human tendency, that's the perfect place to start to really get a handle on how bias sneaks into AI.
See, the thing is, AI is a lot like us. It can be biased. It doesn't just wake up one day with its own opinions. No, it learns, and it learns from whatever we give it. So if the data we feed it is already a bit, well, flawed, or maybe it's a skewed picture of the real world, the AI just learns those flaws as if they're the absolute truth. It's that classic saying, right? Garbage in, garbage out.
Okay, so let's get into the nitty-gritty. First up, we've got something called measurement bias. And honestly, the best way to wrap your head around this one is to imagine you're timing a race, right? But here's the catch. Your stopwatch is busted right from the get-go.
So what this really means is that the tools you're using to collect your data are just wrong. They're inaccurate. It's an error that happens right at the source, which means every single piece of data you collect has that same mistake baked right into it.
And this blood pressure cuff example, it makes it super clear. Imagine a cuff that's not calibrated right, and it always reads, say, 5 points too low. Every single time you use it, you're getting a warped picture of someone's health. The data isn't just a little off, it's fundamentally broken before you even start your analysis. So what do you think happens when you train an AI on thousands, maybe millions, of these faulty readings? Well, the AI doesn't know any better. It just takes that error and accepts it as fact. It builds its entire understanding of the world on a foundation of bad data. And that leads to predictions that are not just flawed, but potentially really, really dangerous.
All right, so that's measurement bias. Now let's move on to the next one, sampling bias. Now this one's a little different. We're not talking about broken tools anymore. This is all about what happens when you train an AI on a really skewed, totally unrepresentative slice of the world.
Basically, this pops up when the data you're using to train your AI model just doesn't match the real world it's supposed to work in. It's like you've taken a tiny, specific sample from the world and tried to pretend it represents everybody.
Think about it like this. Let's say you're building an AI to predict heart disease. Sounds great, right? But what if you only train it on data from marathon runners? Well, that AI is going to be an expert on marathon runners' hearts, but it's going to be clueless about the risks for the rest of us. It's missing all this crucial info about different diets, lifestyles, genetics, you name it.
And the result is predictable. The AI model becomes a world-class expert on one tiny, very specific group of people. The moment you try to apply it to the general population, it just fails. Miserably. Why? Because it never learned about the messiness and the variety of the actual real world. Its entire perspective is just completely skewed from the start.
Okay, so we've got faulty tools, and we've got skewed samples, but now we're going to get into something a little more personal. The biases that come directly from us, from the human mind. These are like our own fingerprints, and we're leaving them all over the data. And really, you can think of these as two sides of the same coin. On one side, you have confirmation bias. That's our classic human habit of seeing what we expect to see or what we want to see. And on the other side, there's observer bias. That's when our own feelings and subjective thoughts start to color how we actually record what we're seeing. Let's make this super concrete. Imagine a team is building a hiring AI. And his team, they have a strong belief that only people from, say, one specific university are really successful. So what do? With confirmation bias kicking in, they might only look for and collect data on successful employees who, you guessed it, went to that one university. They're totally ignoring other super successful employees who went somewhere else. They're not looking for the truth, they're just looking for evidence to prove what they already think.
Now, observer bias. This one is sneakier. It's when our own unconscious feelings, stuff we might not even be aware of, influence how we write things down. A classic example is a loan officer. They might be looking at two very similar applications, but because of some unconscious bias, they just give a lower rating to one applicant. They might not even realize they're doing it, but their feeling is now part of the data. And this is where it gets really dangerous. That loan officer's gut feeling, their subjective opinion, it gets written down as if it's an objective fact, a risk score. And then, all that historical data, now totally contaminated with human bias, gets fed straight into an AI. And the AI, It has zero context, it doesn't know about unconscious bias, it just sees a pattern. And it learns to replicate that same unfair decision, but it does it automatically, and at a scale we can barely comprehend.
Okay, let's pull all these threads together now. What actually happens when all these different kinds of distorted data get fed into an AI system?
So, just to recap real quick, we've got measurement bias, which is basically faulty tools creating bad data. We've got sampling bias, where unrepresentative data gives the AI a really narrow view of the world. Then there's confirmation bias, where we only pay attention to data that proves what we already think. And finally, observer bias, where our own subjective opinions sneak their way into the data and get treated like objective facts.
And here is the absolute key takeaway. These biases almost never happen in a vacuum. They pile on top of each other. They compound. It's like a dangerous snowball effect. Just imagine an AI that was trained with faulty data, from a skewed sample that was then filtered through a human's own biased lens. The result is a deeply, deeply flawed AI that's out there making real-world decisions, and unfair ones. We're talking about everything from who gets approved for a loan to who gets the right medical care.
And that leaves us with a really big, really important question to chew on. At the end of the day, an AI is kind of like a mirror. It just reflects back the data we show it. So the biggest challenge we face isn't just about building smarter tech, it's about looking in that mirror and asking ourselves, if this machine learns from us, how on earth do we stop it from learning all of our own flaws too?